Hey everyone, Miss B here, and this is Unit 4, Lesson 3 of the Illustrative Math Algebra 1 curriculum. So let's do this homework assignment. This unit is about functions, so this first question here is asking us about a function giving temperature. So function f gives the temperature in degrees Celsius t hours after midnight. So we want to choose the equation that represents the statement at 1:30 p.m. The temperature was 20 degrees Celsius. So we have to be careful of our units here. So T is not whatever time it is, it's how many hours after midnight. And F is the function that gives our temperature. So F is our function, which is great because that's actually, we have all of these here, show F. And we want it to be 1:30 p.m. and the temperature be 20 degrees Celsius. So 1:30 p.m., that's an hour and a half after noon, but not after midnight. So we have a couple things that are going to not be answers for us here. We can't use A because we're not going to use 1:30 as our input because we're using it in hours after midnight, so we're not going to use a time format. We're also not going to use 13:30, which would be the military time or the 24-hour time of 1:30 p.m. We're going to select D because 13.5 represents how many hours after midnight is 1:30 p.m. And then the output is 20 degrees Celsius. So our option here is D. Option B would represent at 1:30 a.m. So if we move on to question 2, this one is about Tyler filling up his bathtub. So Tyler filled up his bathtub, took a bath, and then drained the tub. The function gives the depth of the water in inches, t minutes after he begins to fill the bathtub. So I'm going to underline some of my important things here. T is in minutes. The output is depth of water in inches. And our function is B, so everything here is named B. So we want to explain each statement in this situation. So what goes inside is our input. So anything inside our parentheses is the input number. But the entire statement, so this entire two-piece part here on A, B of 0, that actually represents, it's an expression that represents the output value. So then we're saying that's equal to 0, meaning that our output value was 0. So if we're writing this in a sentence in English, this would be input of 0 minutes and a height output of 0 inches. So you can say at 0 minutes the water was 0 inches, but I'm going to phrase this in a more reasonable way, I guess, or in a less mathematical sounding way. So we can say Tyler began, because that means right when he started, with no water in the bathtub. This is the same thing as saying that at 0 minutes, there were 0 inches of water. Now for the rest of these, we're going to phrase it a little bit more mathematically or more numerically. B of 1 is less than B of 7 would be the math way of phrasing it. So we're going to say the water height at 1 minute, because this represents the water's height at 1 minute. And this represents our water's height at 7 minutes. So even though it's just 1 minute and 7, 1 minute is less than 7, but we're not talking about the input value. The entire piece put together, the function name with the input, represents our output value. So we can say the height of the water at 1 minute was lower than the height of the water at 7 minutes. Okay. Statement C gives us an actual output value. So the part on the left, B of 9, this represents an output value at a specific time. I'm actually gonna, well, I'll keep this the same color. I was gonna switch things up, but so we can say the height of the water at 9 minutes. And that phrase right there represents the B of 9 with the parentheses. But now we have to put equals 11. And this part is a much shorter phrase. We can say is or was. We'll say is 11 inches. And that's our full sentence. The height of the water at 9 minutes is 11 inches. And that's what we have represented here. The height of the water at 9 minutes is 11 inches. Okay. Our next phrase has two representations of output values equal to each other, but they're not telling us what the value is of our output. So for this case, we're going to say that they're equal to each other. So the height of the water at 10 minutes, we're going to say is the same as. And the height at 22 minutes. Okay, so our last statement here is again two statements about the output value. And instead of saying the same as, we're going to say that one is greater than the other because that's what our symbol with the arrow sort of pointing to the right means. It means the one on the right is smaller because the opening on the left is bigger and this one is smaller. That's how I think of it. So the height of the water at 20 minutes is, we can say higher, I'm going to say greater than the height at 40 minutes. And that's it for question 2. So if we look at question 3, we're now looking at functions in terms of temperature. Now this one is again hours after midnight, so the same as our first question, but instead now we get to write our function notation statements instead of interpreting them. So if we're trying to represent an output value, we're going to have the name of the function with the input at that specific time. So f is the name of our function. And I guess I didn't talk about this part, but if it says gives, that means that's what it puts out, or the output. So this is going to be considered our output. If it gives the temperature, that is output. And that's measured in Celsius. And then our input is this one here. So the temperature at 12 p.m., we would say F of, and then 12 p.m. is 12 hours after midnight, so F of We don't know what it is, so we're not going to put equals. It's just going to be that expression that represents the temperature at 12 p.m. The next statement here says the temperature is the same at 9 a.m. and 4 p.m. So we're going to represent the temperature at 9 and the temperature at 4, and then put an equal sign in between to show that they're equal. So F of 9, because it's a.m., so that's 9 hours after midnight, it's going to be equal to, or the same as, 4 p.m., but this is 4 hours after noon, so we have to take the 12 hours and then add 4, so this is going to be F of 16 and not F of 4. We have to be careful when we're doing 4 p.m. So here we get a little bit more complicated if we're doing the warmer at 9 a.m. than 6 a.m. We have to interpret what warmer means. And we know that that is temperature, so temperature is greater. So we're going to say the function value, or the temperature at 9 a.m., so 9 hours after midnight. If it's warmer, that means it's going to be greater than, which means I'm going to use this symbol opening in this direction. And function, and 6 a.m. is still just 6 hours as well, so we get to put F of 6. So sometime after midnight, the temperature was 24 degrees Celsius. And we don't know what time, but we can use our variable to represent that. So we can say at F of t, whichever time that is, so t hours after midnight, it's going to be equal to 24 as our degrees Celsius. So that's it for the front page. Let's flip to the next side. For question 4 here, we're going to select all points that are on the graph of f if we know these two pieces of information here. So f of 2 is -4, and f of 5 is 3.4. Now, this is the only thing that they're telling us about this function. It's not necessarily related to the previous one. So we're going to be interpreting these as x and y values or as coordinate pairs. So we know inside our parentheses is our input. Let me fix that arrow there because I'm pointing a little bit. I want to make sure I'm pointing directly at that too. And our input values are going to be x values. So if we're writing these in coordinate pairs of x comma y, this is going to be 2 comma, and then our output value is that -4, so that's our y value. And I do see that as one of my options over here on the left, so that is one of my options, 2 comma -4. Which also means we're not using -4 comma 2 because that is the flip-flopped version. It's a little bit of a trick answer. We're going to do the same for f of 5. 5 is the input value, so it's our x value, and the output should be 3.4. So now I'm going to look over at my choices on the left and find 5 comma 3.4. That looks like it's choice D. And we are not going to use C because, again, it's the reversed version. E, this option is giving you the two input values as an x value and then a y value, so it's also not correct. So it's just B and D. For question 5, we're going to write 3 statements that are true about this situation. There are a bunch of different statements you can write, but you have to at least use the equal sign in one and the less than sign in another. And because we do have a couple points here that are labeled, I'm going to use those values because they land right on some intersections that I can use those numbers pretty easily. So it looks like with these two we can use the less than sign. It does tell us we need to use f as our function name, and that distance is in feet and our t time is in seconds. So we are going to say, using these first two values, so the function value, or f, of 0, meaning our input at 0 seconds, is going to be less than our output value at 0 seconds. It's going to be less than our output value at 60 seconds. So I'm just reading our x values from the table over here. So 0 and 60, because those are where we find these two highlighted points. So then this would be f of 60. You need to write two more statements from this. I'm just going to give you that one. If you're finding something that's equal, I am going to tell you you need to write a statement where you find two values at the same amount. So say I wanted to write one where it was equal to this point. I do see another point just to the left of it where it looks like the dog was also 4 feet away from the post. So I could use, if I looked at this point and I tried to follow it down to see how many seconds, that looks like maybe 45 seconds. So I am going to write f of 45, meaning the dog's distance at 45 seconds is equal to the dog's distance at 60. So f of 45 equals f of 60. And then you are going to write one more. Of your own. So no third solution on this one. A bunch of the answers are going to be different. So you get to write one more. You can choose any points. You can decide to give a value, but you need to use function statement or function notation in your statement. So let's look at our challenge problem. We have 6x plus 2y equals 12. We want to write a new equation that has these different choices. So exactly one solution would mean the same numbers would plug in and give us, well, actually, this just means another line that would intersect with it. So as long as we make sure it's not a parallel line, we will be absolutely fine. So I can say, even just changing one number. So I'm not going to give you exact values for these either, sorry. You are going to write an equation that would intersect on a graph. I'm going to say AKA not parallel. And a good way to do that is to swap the x and y coefficients, especially if they're different ones. If they're the same, it's not going to have any effect, but to swap the x and y coefficients would work for you to write one here. Now, if we have something with no solutions in common, that is one that is going to be parallel, but we do have to change our intercept, or basically the height of our equation here. So what I like to do with this is instead of changing the coefficients on x and y, we can leave those the same and change the number that it's equal to. So we can say write equation that is parallel. Parallel just means having the same slope. So we can say 6x plus 2y equals, and then this is a number you would plug in, put your own number here. I'm going to write it in red. You're going to put a number. I'm going to write just not 12. Because as long as your number is not 12, that'll be correct. And the last part, which is C, to have infinitely many solutions in common. Elena, we need to have something that is exactly the same. So you could write 6x plus 2y equals 12, but that's not technically a new equation. So what we can do is multiply a number by each of those pieces, 6, 2, and 12. So I can say, I'm going to give you some instructions here in red. So multiply the equation. And I would say by any number, but not by 0 and not by 1. By any number that's really going to change the value, but keep that slope the same. So we'll say except 0 or 1. And if you multiplied both sides of the equation by that number, you would get something that has infinitely many solutions because it would land on the line. And I believe that is it for this question. The next page I have is for lesson 4, so that's for another video.